So 5.3 notes similar to what we were doing with 5.1 and 5.2, where we're talking about angles and triangles, and we're going to be solving our triangles. So we're going to talk about our trig functions. Before we were describing it using our opposite, adjacent, and hypotenuse. So we use SOHCAHTOA to help us remember the sine, cosine, and tangent. But now we're going to talk about it in terms of x, y, and r. Looking at the triangle here, theta always comes from the center, so it always comes around whatever your origin is. So our theta would be here. Y, is that opposite of theta, adjacent, or hypotenuse? That would be our opposite. What about x? Adjacent. And r? Hypotenuse. So I could say that sine, we know sine is opposite over hypotenuse, so that would be y over r. Or cosine, we know is adjacent over hypotenuse, so that would be x over r. So that's where they come from. We're going to kind of go back and forth between using the x and y and the SOHCAHTOA, because I think SOHCAHTOA is a little bit easier for us to remember, but you also want to know like your x, y, and r. So sine goes with the y. So sine is going to be y over r, cosine is x over r, and then tangent is y over x. Now the x and y is just going to be like a point on the graph. And then to find r, we could do Pythagorean theorem. On the next page, we have all 6 trig functions. As long as you know the first 3 and you know the reciprocals, then it's just the flip of those. So sine and cosecant are reciprocals of each other. So since sine is y over r, cosecant, the reciprocal, is r over y. We just flip it. Cosine and secant are reciprocals of each other. So since cosine is x over r, secant is r over x. We just flip it. And then tangent and cotangent are reciprocals of each other. So since tangent is y over x, cotangent would be the flip, x over y. Then again, to find r, we use Pythagorean theorem here. Next, we're going to talk about the signs of whatever trig function that we're finding in each quadrant. So if we were on a coordinate plane, in the first quadrant, all of the signs are positive. Every trig function would be positive. Sine, cosine, tangent, and all of their reciprocals are positive. So this one's the all positive quadrant. If we were in quadrant 2, only sine and its reciprocal are positive. Everything else would be negative. So tangent and its reciprocal and cosine and its reciprocal. If we're in quadrant 3, so this was quadrant 1, quadrant 2, quadrant 3. Only tangent and its reciprocal, cotangent, would be positive. Everything else is negative. And then if we were in quadrant 4, cosine and its reciprocal, secant, would be positive. Everything else is negative. Now we can use the acronym All Students Take Calculus to help us remember which quadrant's which. So starting with the first quadrant, we have all, and then you go counterclockwise. So students take calculus. All right, so looking at the first question here, we want to determine what quadrant we're in. So we have all students take calculus. Now with the first piece of information, that's going to give us enough information to eliminate 2 of our 4 quadrants. So we'll narrow it down to only 2 quadrants left. Now it says sine is less than 0. So this means that sine is negative. In which 2 quadrants would sine be negative in?
S.
T and C. Awesome. So it's not going to be in the sine positive, and it's not going to be in the all positive one. Sine is negative in the tangent or cosine quadrant. Then the second piece of information says that tangent is greater than 0, means that tangent is positive. So out of the 2 quadrants that we have left, which one is tangent positive in? So this one stands for tangent's positive. This one, cosine's positive. So which out of these 2 would tangent be positive in? The tangent quadrant in T. So what number of quadrant would this be? quadrant 3. Perfect. So we are in quadrant 3. So let's look at the next one. Secant, it gives us the reciprocal functions here. Secant is the reciprocal of which trig function? Cosine. So it says cosine is greater than 0, so cosine is positive. In our all students take calculus, which two quadrants would cosine be positive in? 4 and 1, awesome. It's either going to be the all positive or the cosine positive. So we can cross off the sine and the tangent one because cosine would be negative in those. And then with our second piece of information here, it says cosecant is less than 0. Cosecant is the reciprocal of which trig function? Sine, awesome. So if sine is less than 0, it says that sine is negative. Out of these two quadrants, which one would sine be negative in? C. We can't be in the all positive because sine is negative. So we are in the C quadrant. So what quadrant are we in? 1, 2, 3, or 4? 4. Quadrant 4. All right, so we're going to use that for the next questions. We want to determine the 6 trig functions given that tangent is equal to -5 over 3. Now, tangent in terms of SOHCAHTOA is what over what? Opposite over hypotenuse. So opposite over adjacent. So the number up top is going to be our opposite. The number on the bottom is going to be our adjacent. We are going to worry about the negative at the end. I'm not sure if that negative's with the 5 or with the 3. So we're just going to deal with that negative at the end. But I'm going to make a star around it so I don't forget. Don't forget about the negative at the end. Now, how could we find our hypotenuse? Using the Pythagorean theorem, a squared plus b squared equals c squared. Remember, our hypotenuse has to be the c. But we can say 5 squared plus 3 squared equals the hypotenuse squared. So 25 plus 9 equals hypotenuse squared. So our hypotenuse squared equals 34. Take the square root, so what's our hypotenuse? Square root 34. Let's see if we can simplify. What are 2 factors of 34? 2 and?
32. Or no, 32. 34. Sorry.
17. 2 and 17. Can we break it down anymore? No. So we can't simplify square root 34. We're just going to leave it as that. So our hypotenuse is square root 34. Once we find all 3 pieces of information, we need our opposite, adjacent, hypotenuse. We can plug those in using our SOHCAHTOA. We're going to find all of our trig functions now. So sine, cosine, tangent, and then the reciprocals cosecant, secant, cotangent. So we're going to use this to help us. So sine is what over what? Opposite over hypotenuse. So that would be 5 over square root 34. Can I leave a square root in my denominator? No, we have to rationalize. So we're going to multiply the top and the bottom by square root 34. So we get 5 square root 34 over 34. Now cosine would be adjacent over hypotenuse. So that's 3 over square root 34. Again, here we have to rationalize. So we're going to multiply the top and the bottom by square root 34. So we get 3 square root 34 over 34. Then tangent was actually given to us. That one is opposite over adjacent, so 5 over 3, but the negative's there, so we'll say -5 over 3. Now let's find all of our reciprocal functions. We're going to flip our three main trig functions. So cosecant goes with sine. So I'm going to flip the sign before we rationalize. So that would be square root 34 over 5. Secant goes with cosine, so I'm going to flip it before we rationalize. So square root 34 over 3. And then cotangent goes with tangent, so that would be 3 over negative 5. Now we have to deal with that negative here. We got to figure out what quadrant we're in, so what else is negative? So we're going to use our all students take calculus. We're in quadrant 4. This is the Roman numeral for 4. So in quadrant 4, what's going to be positive? Cosine's positive. Cosine and its reciprocal are going to be positive. Everything else is going to be negative. So that means sine is negative, cosecant's negative, tangent's negative, and cotangent's negative. Only cosine and secant are going to be positive. So you can either do it at the beginning where you check the sign so you know what's going to be positive, what's going to be negative, or you could do it at the end. If you save it for the end, just don't forget about it. All right, so looking at secant is equal to negative 2. How would I make negative 2 a fraction? Awesome, negative 2 over 1. So according to SOHCAHTOA, secant goes with which trig function? Cosine. So if cosine's adjacent over hypotenuse, then what does that mean secant is? Hypotenuse over adjacent. So hypotenuse over adjacent. Now that we're going to pretend that negative's not there, we're just going to deal with all of the signs at the very end. But if I have my hypotenuse and the adjacent, how would I find my opposite? Pythagorean theorem. So I could say opposite squared plus a squared equals hypotenuse squared. So opposite squared, let me plug in. Our adjacent is 1 and our hypotenuse is 2. So opposite squared plus 1 squared equals, 1 squared would be 1, equals 2 squared, which is 4. Subtract 1 on both sides, so our opposite squared equals 3. Take the square root. So our opposite would be square root 3. Well, it's just O for opposite. I realized after I wrote it that it looks like a 0, but if you wanted to call it X or A, whatever you want to call it, I just put O for opposite. All right, so our opposite is square root 3. Once we find our opposite, adjacent, and hypotenuse, let's find our trig functions. So sine, cosine, tangent, and our reciprocal functions are going to be cosecant, secant, cotangent. Now, according to SOHCAHTOA, sine is what over what? Opposite over hypotenuse, so that would be square root 3 over 2. Cosine is what over what? Adjacent over hypotenuse, so that would be 1 over 2. And tangent would be opposite over adjacent. So what's our opposite over adjacent? Square root 3 over 1. How could we write that better? Yeah. Just square root 3. We don't need the 1 when it's in the denominator. All right, cosecant is the reciprocal of sine, so that would be 2 over square root 3. Can we leave our answer like this? No, we have to rationalize, so multiply the top and the bottom by square root 3. So 2 square root 3 over 3. Secant was actually given to us. That's just negative 2. That was part of the question. Cotangent, we're going to flip tangent. So instead of square root 3 over 1, it'd be 1 over square root 3. Can we leave our answer like this? No, we have to rationalize. So we get square root 3 over 3. Now the last step, Santia.
Why do you put -2 like the -2 and not like cosine? Like, why is it not negative?
Cosine will be negative, but I just saved the signs for the very end.
Okay.
So it tells us that we're in quadrant 3. So we have all students take calculus. Which one's quadrant 3? Tangent. So what's going to be positive? Tangent. Everything else is going to be negative. So tangent and cotangent are positive because the reciprocals go with each other. So tangent and cotangent are positive. Everything else has to be negative. So that means sine is negative, cosine's negative, cosecant's negative, and secant's negative. So I just didn't put that the 1/2's negative when I was working it out because I saved it for the end. But if secant's negative, then cosine has to also be negative. Yes, yes. We have one question left if you want to wait 1 minute. It'll be quick. Any other questions here? Awesome. We're going to jump to the last page. All right, so for part 2, so 5.3 part 2. In the notes, either 5.1 or 5.2, we talked about coterminal angles. Coterminal angles end at the same spot as each other, but to find a coterminal angle, you can add or subtract 360 as many times as you need to. So we're going to talk about that a little bit more today. Coterminal angles, they stop in the same spot, but if you have a number that is bigger than 360, you want to find a coterminal angle of it. So we'll talk about that. Another thing is we need to know what quadrant each angle falls into. So in quadrant 1, we're talking about angles in between 0 and 90 degrees. In quadrant 2, we're talking about angles in between 90 and 180. In quadrant 3, 180 and 270. And then in quadrant 4, angles in between 270 and 360. So with example 1 here, we're actually going to look at our unit circle to help us with this. So if we have the cosine of 135 degrees, we're going to look at 135 on our unit circle. So that would be here.
Where did you get that?
All right, so the point that we have at 135 degrees would be this point here. So we have negative square root 2 over 2, comma, square root 2 over 2. Now going back to what we did yesterday, we talked about sine, cosine, and tangent in terms of x, y, and r. Cosine is x over r. When you're on the unit circle, it's called the unit circle because r is just one unit. So when you're on the unit circle, r is 1. And then this point would tell us our x and our y. So since cosine is x over r, what is our x value?
Negative square root 2 over 2.
Negative square root 2 over 2. It would be over 1 because we're on the unit circle, so r is just 1. So this would be our answer. This would be the cosine of 135 degrees. Let's do the same thing for tangent. However, 390 degrees is not on our unit circle because it's more than 360. How could I find a coterminal angle that's in between 0 and 360? Subtract 360. So you can add or subtract 360 as many times as you need to find an angle in between 0 and 360. So now we're finding the tangent of 30 degrees. So I'm going to go to my unit circle, go to 30 degrees. And we're looking at this point here. So our point would be square root 3 over 2, comma 1/2. Now going back to the second slide, tangent tells us we look at what over what. So y over x, where this is our x and our y. So y over x would be 1/2 over square root 3 over 2. Now, what do we do if we have a fraction and a fraction? We do multiply, but what else do we do?
You flip.
Keep, change, flip. Keep the top, change to multiplication. We're going to flip the bottom to 2 over square root 3. So if we have a common factor in the top and the bottom, they'll cancel. So the 2's cancel out. So this would be 1 over square root 3. Can we leave square root 3 in our denominator? No. So we want to multiply the top and the bottom by square root 3. We got to rationalize. So we end up with square root 3 over 3. So this would be our answer. All right, next thing we're going to talk about are reference angles. Reference angles are like the smaller version of the angle we're given. There's two things that we want to keep in mind when we're talking about reference angles is that they have to be acute and positive. Does anybody remember what acute means?
Small.
Below 90.
Less than 90. Less than 90 degrees. So acute means less than 90 and it has to be positive. So these are two things that our reference angle has to be. Now, depending on which quadrant we're in, we have a different formula that we use. So if we are in quadrant 1, whatever your reference angle is going to be the same thing as your theta. If we're in quadrant 2, we do 180 minus theta. If we're in quadrant 3, we do theta minus 180. And if we're in quadrant 4, we do 360 minus theta. So you have to know which formula you use whenever you're in that quadrant. But if you happen to use, bless you, if you happen to use the wrong formula, your answer is not going to be acute and positive. So if you use the wrong formula, your answer will not be both acute and positive. You'll be able to check your answer that way. If you get a number that's bigger than 360, you need to think, did I use the right formula? Or if you get a number that's negative, you need to think, did I use the right formula? So depending on which quadrant you're in, you use a different formula. Your answer has to be acute and positive. So example 2, we want to find the reference angles. Now, in order to use the formulas that we talked about on the last page, our starting number has to be in between 0 and 360. Now, it's a little bit harder when we're given radians to tell where that falls in our quadrants. So let's convert it to degrees. So what would we need to multiply by to convert this to degrees? 180 over pi. So the pi's cancel, and 3 goes into 180 how many times? 60. So our theta would be 5 times 60, so that is 300 degrees. In what quadrant is 300 degrees in? 1, 2, 3, or 4. In quadrant 4, we'd be here. So what formula do we use when we're in quadrant 4? 360 minus theta. So we do 360 minus 300. And that'll give us 60 degrees. Now this is our answer for a reference angle, but if our answer is if our question is in radians, the answer also has to be in radians. So we have to convert it back to radians. So I'm going to multiply by pi over 180 to convert it back. So 60 goes into 180 how many times? 3. So this would be pi over 3. So this would be our reference angle. So if the question is in radians, your answer also has to be in radians. So if you convert it in the beginning, you just have to make sure you convert it back for the reference angle. Remember, the reference angle is like a smaller version of your angle. So if your angle is radians, your reference angle needs to be radians. All right, let's do B. So we're starting with theta is 870 degrees. This is more than 360. So what would we need to do? Subtract 360. So before we can even plug it into one of our formulas, we need to make sure it's in between 0 and 360. So when we subtract 360, we get 510. 510 degrees is also more than 360. So what would we need to do now? Subtract it again. So subtract 360 again. When we subtract 360, we get 150. All right, so 150 degrees is in between 0 and 360, so we're good here. What quadrant would 150 degrees be in? Quadrant 2. In quadrant 2, what formula do we use? 180 minus theta. Perfect. So we would do 180 minus 150. So what's 180 minus 150? Awesome. 30 degrees. That would be our reference angle. So if your question is in degrees, your answer, you want it to be in degrees too. So you don't have to convert anything when it gives it to you in degrees. So in example 4, we're going to find the reference angles. So in A, if we start with radians, what should we do first? Convert it to degrees. So I'm going to multiply by 180 over pi. The pi's cancel, and 3 goes into 180 how many times? 60. So I'm going to multiply 16 times 6, and then just add the 0 at the end. So 6 times 6 would be 36. 6 times 1 is 9 plus... No, 6 times 1 is 6, plus 3 is 9. So this would be 960. So 960 degrees. This is more than 180. So what would we need to do? Subtract by 360. So when we subtract, we get 600. 600 is still more than 360. So what should we do next? Subtract 360 again. When we subtract 360, we get 240. Perfect. So this number is in between 0 and 360. So we can figure out what quadrant we're in. Quadrant 3, perfect. If we're in quadrant 3, what formula do we use? Theta minus 180. So our theta is 240 degrees minus 180. What's 240 minus 180? 60. Can our answer be in degrees? No, because the question was in radians, so we got to convert it back. So I'm going to multiply by pi over 180. 60 goes into 180 how many times? 3 times. So we get pi over 3. Any questions here? Let's do it again with B. So let's start by converting it to degrees. So we're going to multiply by 180 over pi. 4 goes into 180 how many times? 45. Perfect. So this would be negative 45 degrees. Is negative 45 degrees in between 0 and 360?
No.
No. So how do we find a number in between 0 and 360?
You add.
Add 360. So when we add 360, we get 315. What quadrant would 315 be in? Quadrant 4. What formula do we use in quadrant 4? 360 minus theta. So we do 360 minus 315. And we get 45. Can we leave our answer as 45 degrees? No, what do we need to do? Convert it back to radians. Our question was in radians, so our answer has to be in radians. So we want to multiply it by pi over 180. How many times is 45 going to 180? 4. So our answer would be pi over 4. So looking at the last page, it says find the area of a triangle. So our area formula is going to be this here, where we have 2 sides times the sine of the angle divided by 2. So we just multiply side. It doesn't matter which side's your A or your C, so you're just multiplying them together. So 3 times 10 times sine of the angle. Whatever your angle is, that's what you're taking the sine of. So sine of 120 over 2. Then we can just put this in the calculator. Because 120 is in degrees, make sure your calculator is in the degree mode. So 3 times 10 times sine of 120 divided by 2 should give you 12.990. We'll round to 3 decimal places. And then because we're talking about area, our unit's going to be centimeters squared. So this question, you just put it in the calculator.